All right, guys, this is just applications of what we did last class. So it's nothing really new, but I'm going to go through a few of these with you so you have an idea of what to do, and then I'll have you try the rest on your own. So have the PDF open so that you can work through the rest, and I'll have the answers posted afterwards. So we're going to do the first three together, and then I'll have you try the last few. Just a reminder, you have some textbook homework due as well, so just take your time on these, and the textbook homework problems are kind of a variety of what we've done over the past 2 days, so let me know if it takes you a little bit longer to do, and I'll give you some more time. All right, so we're going to start off with the application of these. So these are just real-world applications of the three variable system. So what you have to do is define what your variables are. So the sum of three numbers is 20. We can say that those numbers are x, y, and z. You can make them a, b, c, whatever you want. But it says the sum of them is 20. There's our first equation. The first number, aka x, is equals the sum of the second and the third. There we go. We already got two equations down. The third number, aka z, is 3 times the first, so find the numbers. All right, so we have our three equations. The nice thing is that I already know that z equals 3x, so I'm actually going to substitute that in for this equation, and then we'll have one less equation to work with. So this is a lot like those first set of questions we did where you can just substitute in and go for it, which is nice. Okay, and then I end up with negative 2x equals y. So then I can actually sub that in up there if I want to. So then I can say, let's see, so negative 2x is y. So x plus negative 2x plus z, but z is really 3x, equals 20. So now I'll have all one variable by just using substitution. Most of the time we're going to use elimination for these questions, but this one was convenient. So that gives me 2x equals 20, so x equals 10. So I already have my first number, so it's going to be 10, comma, and then I just have to substitute back in. I'm actually going to solve for y next because that's my next number in the pattern, but also I can just plug it back in for that equation. So then I have negative 2 times 10 is y, which is negative 20. And then the third one, I can plug in either for the original equation, the top one, or remember z is 3x. So you can say 3 times 10, which is 30. And if you add all those up, it gives you 20. And the first number is the sum of the second and the third. And the third number is 3 times the first. So we're good to go. So you just check back in to make sure that your answer makes sense. All right, for the second one. Last Tuesday, Apple Cinemas. I think that's the new name. Used to be Hoyt's, right? Sold 8,500 movie tickets. Obviously, that's not true right now because sadly we can't go to the movies. Proceeds totaled $64,600. Tickets can be bought in one of three ways. Okay, so this is your hint that you have your first equation. A child under 5 years old costs $5. Okay, so we got one part there. Student tickets are $6 and regular tickets are $8.50. How many of each type of ticket was sold if twice as many student tickets were sold as children under 5 years old? Okay. So first of all, we sold 8,500 movie tickets. What I would recommend doing is giving each type a variable. So I would say that x equals under 5 years old. What is that? Students is next. So yep, students is y. Students. So with these, I actually have to define what they are. And then z would be regular. Okay, so I know that they sold 8,500 movie tickets. So I can say x plus y plus z equals 8,500. There's my first equation, right? Then it says children under 5 years old cost $5. Students are $6, and regular tickets are $8.50. So because I'm given the cost, a total, how much we made altogether, I should put the cost in there for each of them too. So the first one would be 5x because it's $5 per child ticket, plus 6y for students, plus 8.5z, right, for adults. So there's my second equation. The last equation, it says how many of each type of ticket was sold if twice as many student tickets were sold as children under 5 years old. So what we end up having to do here is thinking about if there are twice as many student tickets as children, that means that y is going to equal 2 x's, right? Because there are twice the children tickets for y's, if that makes sense. So from there, I would, it's kind of like the first question, just go back and substitute back in. So you can actually substitute 2x in for all the y's you see, and then it's actually a pretty nice equation to solve. So I'll actually have you try that on your own and see if you get the same answer as me. So you can pause, and when you're done, I'll have the answer for you. Alrighty, so hopefully you got that there were 900 kids that had tickets sold to them. I showed the workout up here if you need to check how I got it, but what's nice is you can use substitution to plug in 2x for all the y's you see. Just be careful because if you plug in the 2x here, it's 6 times 2x, which is really 12x. Combine like terms, and then you have a 2-variable system. So I decided to multiply by something kind of gross, like the negative 8.5 is not pretty, but it's easier to do that than multiply by something crazy. You could also use substitution here and solve for z and then substitute that in for the other equation, but you should get 900 for x, and then you know that y, or aka students, are double x, so that has to be 1800, and then finally I used this equation to plug in what x and y were, and then I just subtracted them to get z. So your final statement you should write out. I don't have a lot of room, so I would say there were 900 children tickets sold, 1,800 student, and then 5,800 regular tickets sold. For number 3, again, let's set it up together and then I'll have you try it. There's a few more I want you to work through on your own, but an amphitheater charges $75 for each seat in section A, $55 for section B, and $30 for lawn seats. So they're telling you that that's your X is for A. Technically you can use A, B, and L as well if you prefer, but I tend to use X, Y, and Z a lot. Y would be for section B, and that means that Z would be for lawn seats. So that would be L. Okay, so then there are 3 times as many seats in section B as section A. So 3 times as many in section B as section A. The revenue, 3 times as many Okay, so then the revenue from selling all 2,300 seats is $870,000. So that actually gives you both of the other equations, because they're saying that x plus y plus z is all the seats added together, and that's 23,000. And then we have to throw in the price if they're saying how much the price is, right? So that means that it's $75 for X, $55 for Y, and then 30 for Z, okay? Because this is super similar to the last one, I'm going to have you solve it on your own and see if you can get it. And then I'll pause the video, have your answer, and then I'll have you try the last few that are on the next page and the page after. So again, this is going to be more individual at this point, but again, feel free to join my office hours if you're still struggling. All right, guys, hopefully you got 3,375 for X, 1,125 for Y, and 18,500 for Z. So what that means is they sold, you kind of want a final statement here, especially if you have room, sold 3,375 A seats, 1,125 B seats, and 18,500 lawn seats. If you didn't get those answers, just know that you can, again, this is kind of nice that they had a lot of substitution here, but because X equals 3Y, I plugged it in for this, and then also that. Just be careful that this one you'd have to do 75 times 3 times Y to get the 225. And then I multiplied, once I combined like terms, by negative 30 on the top, because then that cancels out your Z's. You can do the same thing by multiplying by something to get the Y's canceled, but that's how I got my Y first, and then I can plug it back in up here. And then once you get X, you can plug it back into this equation if you want to, or what I actually tend to do is I used this 2-variable system and plugged in Y and then solved for Z because it's much easier to get one variable alone that way. All right, guys, I'm going to have you try the rest of these on your own. Just be careful with the percent question because you want to use decimals there. So like 4% is really 0.04, things like that. Same thing with the cents. So 32-cent stamps are 0.32, things like that. And then, all right, so once you're done these problems, I'll have the answers for you without a whole lot of work, so just be careful on that. But you should be good to go after that, or join my office hours if you have questions. Have a great rest of your day. All right, so if you try these questions first, what I did was write out the equations for them, and then I wrote the answers. So for the first one, you get X plus Y plus Z equals 12. Again, I chose X, Y, Z to be my numbers. For my second one, the first number is 5 times the second. So you can do literally X equals 5 times Y, and then the sum of the first and third is 9. So those were my 3 equations, and you should get 15, 3, and negative 6 for your numbers. For number 5, you have to write out something a little different. So notice what my equations are. You have to say that Y, I said Y was my 29-cent stamps, X was my 32-cent stamps, and then Z was my 30-cent stamps. So you get these 3 equations, which you should see here. This one you have to use money. So that's why I was saying before that you had to use 0.32 for 32 cents, 0.29 for 29 cents, and so on. And then I ended up with, just write like a final statement here, but he has 20 32-cent stamps, 10 29, and 5 3-cent stamps. The last one on this page, Aiden borrowed $30,000 to pay for tuition, room, and board. So some of the money was borrowed at 4, and then 6, and then 8. So I labeled each type of money because some of the money was borrowed here, here, and here. So I said X was the first percentage, Y was the second percentage, and Z was the third. So that's how you end up with these 3 equations. There was about $20,000 borrowed at 4%, $2,500 at 6%, and $7,500 at 8%. And then the last one is on the next page. Last question is, again, really, really similar. You have a little bit more room on that one. But eventually, we're going to solve all of these a little bit faster once we start learning about matrices, which we're going to do probably next week. So this is the last one. I use slightly different variables just to change it up a little bit, but I use C, R, and D to equal carnations, roses, and daisies. And you would want to define what those are off to the side first, and then write your equations, show your work, and so on. But hopefully you can check out my equations, and hopefully you did okay. If you're ever confused by these statements where they say, like, they ordered 20 fewer roses than daisies, try to set up your equation and plug in something and see if it makes sense. So if you're not sure about the order of this, if I plug in like 40 for daisies and then I subtract 20, I get 20 fewer roses, right? So this helps you with this second equation. So you end up with 80 carnations, 50 roses, and 70 daisies. If that took you way longer than you thought it would, just pause on the homework if you don't have that completely done. But you should try to get that done at some point before next week, just to let me know if you have questions. We have a little mini assessment on Friday, so it might be a good idea to get them done before then. But anyway, I hope you have a wonderful rest of your day, and I will talk to you soon.